Hi, good morning. Welcome to the fifth lecture of Form and Space and the lecture series of History of Architecture and Structural Design. Today we're going to talk about concrete and shells and spaces built out of concrete and with shells. So I wish you an informative lecture and hope you have also fun. Just let me give you a short summary of what we talked about in the last lecture, perhaps in the last one or two lectures. What happened so far. So first let me come back to the Greek and the Roman ancient architecture, and we saw structures, columns and beams. These kind of building set standards for centuries, and sure, it's not only marble to build these structures with. One can also use wood, steel, concrete or other materials. And so walls, arches and domes are also elements developed in that time, in the period of time, and make, so to speak, school in later centuries. So the people coming after the Roman architects, they learned from these kind of buildings, and that what I like to tell you is your task to look in the history to find examples and to get inspired by these kind of historical constructions and historical ways to shape spaces. For example, Mies van der Rohe designing the new National Gallery in Berlin in the 1960s after the principle of a Greek temple. But this is not a religious building, and it's not built out of marble or stone. It's created out of steel. Well, as it is the task of architecture to define and to create space, to close or to open space, or to define the line between the outside and the inside, it does not actually depend on the material, but there is more or less materials recommended, stones for example, but one can also use wood, concrete, and as the Roman did it already, but it's probably not recommended to use wood for arches and domes. But there is a relation between the material and the construction. So if you take a look at the Gothic architecture, for example, which is thinkable in wood, but it's really recommended to build these kind of buildings out of stone, as we saw it in the examples I showed you in further lectures about the Gothic architecture. So the Gothic architecture is also important as an epoch of architectural history, like the Egyptian period, the Greek period, the Roman, or other periods, or in other regions. For example, you can find the pointed arc also in the Ottoman or the Moorish buildings. But these kind of periods, they are typical for a period of time, but it's more than a fashion. If you design architecture, is nothing about fashion, I should declare, because it depends on principles, and it depends how to use the material and how to fulfill the tasks architecture gets off. And the material, for example, in different periods there were different materials available. Long time the people used wood, then they used stones, then they used marble as stones, and as I told you, the Roman already started to use concrete. So then they're trying to get more and more into special situations. So it is recommended, and if you can take time to go to southern Spain and visit the Alhambra or the Cathedral of Valencia, you can see the Gothic as a system of arcs and columns, and it creates a special space even for sacral buildings like churches. Well, light, transparency, and the promise of the paradise has an important meaning for the quality and the atmosphere of space, and also the dissolution of walls is important. So what is about the relation between structure and material? When iron and steel came up in the middle of the 19th century and became a very successful material used for the buildings, then it caused a little bit of a revolution in the buildings. So you have more transparency, you have a light white, and you had a lot of opportunities to use this material. But you can see that architects and engineers learn from the history and tried to achieve also transparency, to achieve long distance construction, and to create spaces without columns and free spaces, free inside spaces, which is very important for the architecture. So these materials just made something like a revolution in the kind of buildings in the middle of the 19th century. As I told you, is steel very much recommended to cover the tensile forces, and I showed you with this picture how that works and how you can achieve to overwhelm distances, long distances, with the principle of tensile forces. Steel is not really recommended to be used to cover compressive forces, but you see the tendency in which it goes. But steel can be more than columns, beams, and arches. It can be a structure in itself, a network, and thanks pioneers like Konrad Wachsmann. You see a tribute by the Burkhard Sumi architects at the Architectural Biennale in Venice, or Max Mehringhausen, who designed the Mero knot, for example. Or if you take a look at the construction and the theories of Richard Buckminster Fuller, you can see that the material steel and the thinking in geometric spheres can cause some new creations of spaces and new creations of construction and at least of architecture and visions, if you like. And finally, Richard Buckminster Fuller opened a new dimension of building, and he was creating spaces with private skies, domes, and shelters. So, as you can see, the history of architecture depends on the opportunities of materials the thinking and the theories of architecture, and the possibilities, the technical possibilities. So to say architecture depends on fashion is probably wrong. I can see it depends on cultural influences from different periods of time and of different opportunities. So today we're going to talk about concrete and shells. And before we got really in the center of this kind of building, history of building and history of architecture, I'd like to remind you two or three other points I made in the further lectures. I'd like to remind you on this planetarium building in Jena from the year 1926 in Germany, and it was designed by the engineers Bauersfeld from the company Zeiss, which is an optical company constructing projections and projectors and other optical things, and the engineers, the civil engineers Dischinger and Finsterwalder, the both are working for the construction company Dyckerhoff and Wittmann, called short Duvidac. And they constructed first the dome out of the triangle, five-angel hexagon geometry, and put these things, these geometry together to construct a dome out of steel, and then it was combined with concrete, and the result is the building you see on the left. I think it's boring to talk about concrete and steel as an all-day building material, what it obviously is. If you look around, you can see it at any construction site. It's a quite practicable material. Cement, water and sand mixed together, steel to enforce it, and a good formwork. It's easy to do, but you have to know how. I think it's a good reason to study architecture, civil engineering and geodesy, and therefore I like to show you buildings or ideas of engineers and architects who are challenged by these kind of things, or inspired by, also by all-day things they saw around. I like to come back to this picture I showed you before in the last lecture. Konrad Waxman took a photograph of this fisher net, and if you look carefully you can see it's a kind of flexible network, and it shows also the parabol ideas, and if you were capable, and I think that has Waxman in his mind, if you can fix this nets, then this network, and then it could be the basic, for example, of a building. Waxman called this picture, this image, nets as a symbol of tensile forces. And there was another architect inspired by this idea I also already told you about, Antonio Gaudí, and his idea to build a model of chain. So he designed, so to speak, a complex network and a complex system of parabolic hanging chains and nets, and his idea was to fix it, and as I told you, he realized this idea in a couple of buildings. The top and the important building was the Cathedral of Sagrada Familia in Barcelona. We saw it in the last lecture. So the idea of the planetarium in Zeiss comes along with another very important technique which was developed at that time is the technique to spray the concrete, to have a very fluid material and to spray it like you can see it on the picture on the right, which is a contemporary picture I took not out of the time, but the technique is the same. So they achieved to build a dome in this particular case in a very slim concrete form. It is also 5 to 8 centimeters strong. So the steel and the concrete in this combination, important technique developed by Walter Bauersfeld for the company of Carl Zeiss, the optical company, and the construction company Dückerhoff and Wittmann by Franz Tischinger and Ulrich Finsterwalder. So the technique became very famous in the combination name of Zeiss-Duvidac. And the technique was, so to speak, a breakthrough to design huge volumes and huge halls. For example, this wholesale market hall in Frankfurt am Main, designed by the modern architect Martin Elsässer a few years later than the Zeiss Planetarium. He constructed that building with barrel walls, tunnel walls, so to speak, and you can see on the picture on the right, down at the right, you can see how it was constructed. It is a fixed steel network with knots. It was constructed, and then they sprayed the concrete on top, so they have a barrel vault, tunnel vault, wagon vault, so to speak, to cover the whole market, and so they have no columns, no a very free and huge area where you can hold the market, where trains can get in. So it was a real breakthrough and a new kind of architecture and a new kind of space. You can see this hall became very famous, and now it is, so to speak, the basis of the building for the European Central Bank, built by Coop Himmelblau a few years ago. They just, well, it was a little bit brutal because they cutted all these construction and put the tower just inside, but on the other hand, parts of the buildings were left, and we can still see this breaking through construction for market halls. Well, the spaces the architects or the engineers achieved with this kind of construction was still very classical building. You can remember the Pantheon, or you can remember all old constructions of these barrel walls in Roman times, for example, or in other periods. But the combination of concrete and steel understood in a network gives you another freedom, let's say, to construct other spaces. You can form the net as you saw it in the image of Konrad Wachsmann. You can form it, for example, in two directions, in two dimensions. And if you form the network and if you are capable to fix it, then you can achieve a very free and new kind of space. Yeah, for example, in this pavilion, Le Corbusier and Yannis Xenakis, he was an employee or a partner in his bureau, in his office, and by the way, a very good musician, Yanis Xenakis, and a civil engineer. And so these both developed the form, or maybe mainly Yanis Xenakis, developed this form of this pavilion, the Philips, so-called Philips Pavilion, on the World Exhibition in Brussels in 1958. And they constructed a so-called hyper shell, so it's a hyper-paraboloidic shell. It's a complicated word, but it says nothing more than it is a double curved shell. So if you remember what I said before, is if you have a network of steel, then you can form it like a textile, and you have this steel form, and then you fix it with a formwork, as you can see in the picture on the right, and you can fill it up, or you can fix it with concrete. And at least, and this is the most important challenge, I think, in this particular case, is that they achieved a very interesting and very new kind of space in the inside of the building, as you can see it on the ground plan. Well, the ground plan is not says nothing. There's nothing about the third dimension you can achieve with this form, and it must have been spectacular. But unfortunately, this pavilion is not existing anymore, so we have to look at these small ground plan. There are just a few pictures, and I don't know how to get these pictures, but this is a very interesting space. 1 year earlier, in 1957, the Italian architect and engineer Pierluigi Nevi had studies, or made studies for this church in a monastery, and this form is quite more easy. You can see this double curved shell, and you can imagine that there is also a very spectacular space inside, and a good reason to form or to design to design this building as a church. So the inside space is really spectacular. The Swiss architect and engineer Heinz Isler produced in the 1960s halls like this, and for a tennis court, for example, covered a whole court, or a motor stop at the motorway, a restaurant, and the idea is to span over long distance. It reminds me a little bit on the ideas of Buckminster Fuller, to cover whole spaces with these very huge and slim shells, and to construct in a way an extraordinary or something like a private space. These constructions are very light, so they have not too much weight, and it's very slim, so there is a huge challenge in between inside of these construction, and so it became a fashion in the 1950s and the 1960s to use these kind of constructions, but also not only in Europe but also in South America, and I'd like to show you some more examples of that. For example, Felix Candela in Mexico, and you see this example, the church in San Jose, Monterrey, and well, I have to say there is another very important technique to design and to construct these kind of shells on buildings, and this is called the pre-stressed steel and concrete steel, where you have you pre-stress, so to speak, the steel elements, so then they are capable to cover more forces, and this was in a way the basis of other of these kind of construction, also as the Torcrete concrete spraying system, what we see later, when we see later some more examples of. So this is a church again, and you see it under construction on the right up in the building. You see they use wood for this formwork, and so they have a very complicated formwork. They put the steel inside and combine it with concrete, and you need a huge knowledge of geometry and mathematics to construct these buildings. Another example of this engineer architecture is this restaurant by Felix Candela, with a double curved or multiple curved shell. The shell itself is both. It's a wall and a roof, and you have a very spectacular space inside, as you can see on the picture up on the right. So the shell does not only cover the function of the roof and the wall, but also includes the columns. So the shell has just a few defined points where it touches the ground. It's in the outside, on the ring outside, and then you close the outside with these huge windows, and then you can achieve this spectacular open space to use as a restaurant, as you can see it on the picture up on the right. And I'd like to show you also the construction space. It looks quite simple. They have a formwork, quite complicated constructed formwork out of wood. So the main construction also obviously is to build the formwork, and then they use a lot of manpower to bring the concrete on top of this formwork and to finish it. Lots of people, lots of men working on this construction site. Another example I'd like to give you from South America is the work of Eduardo Dieste. He was an engineer and an architect, and he was also someone who's leading a construction company. And he uses this very slim and very effective system of the shells, as you can see it in this small monument you see on the picture down on the left. And what is obvious is that it is a high complicated work of an engineer. So it's really complicated form and a complicated formwork and a complicated calculation and construction of it. But at least it is quite simple to build it. If you achieve the formwork, then you can do the rest in a very simple way, as we saw it on the construction site in Mexico also. And Dieste had another trick, so to speak. He uses brick, and he brings the brick inside the formwork. He's covering it with a steel network and adding the concrete on top, and then he finished it with a skin to save it against the rain and other inputs, so to speak, from the surroundings. So the sun in South America is also very important. So if the concrete dries too fast, then it also can be problematic. But the effect of the bricks inside the formwork has the effect that you also have finished a very nice surface, as you can see it on the church he designed on the image on the top on the left. And there's something else I'd like to show you on this slide. First thing is that Eladio Dieste is using these shells not only in a very simple way, he is using it to shape, so to speak, the space and to bring in the light, as you can see it on the picture on the right down. So he is playing with these opportunities and possibilities of simple and complicated constructed shells. This is one thing, and the other thing is that he is using this technique not only to design spectacular spaces or important spaces like churches, what you see on the picture on the left. He also used this for warehouses. The picture on the right and on top shows something like that, and also the picture on the right down. So he's using this technique not only for spectacular spaces, but also for all-day spaces, for big halls, for big warehouses, just to cover the ground or to cover a space and to achieve a free space without any columns, where you can go very easily, like for example with staples and these kind of vehicles. Well, let me come back to Germany, to Europe, to Germany, especially to Hamburg, as we are in Hamburg, and I'd like to show you some buildings which you can also see if you look around in the city. For example, if you go to the University of Hamburg, perhaps you have the chance to see the Auditorium Maximum, Audi Max. Well, this building was designed by the architect Bernhard Hermkes. I already told you about him. We saw his palm houses in Blanton und Blumen Garden, and well, he was in contact all the years through the 1920s when he started his career in Frankfurt, and he was building as an architect, working as an architect all the time, and he was working for the industry. He constructed factory halls, and he was really in, I suppose, in very strong contact with engineers like Dischinger and Finsterwalder. I told you about them from the 1920s. They worked very successfully with this size construction company, and they constructed elements for the industry in Germany. I will come back to that issue later in the next lecture. So he constructed these kind of shells and these kind of concrete work, for example, for this Auditorium Maximum. Here we have a picture from outside, and if you are in very close to the university or have a chance after Corona to listen to a lecture, there you can see how he constructed this. You can see it on the front. You can see a very slim roof, very tiny columns, and the inside is completely free without columns. On top I have some pictures as the image we saw before from the construction area, from the construction site. Another very, in this sense, a very important building are the wholesale market halls in Hamburg. in Hammerbrook. They were also designed by Bernhard Hermkes, and in 1958 to 1962. And the engineer was Ulrich Finsterwalder in this particular case, and they're using this still very famous and important technique of Zeiss Duvidac. So the shell, the prefabricated shell, Zeiss Duvidac was very successful during the Second World War to design factory buildings, and so it was very important, I think, for Bernhard Hermkes to work together with Ulrich Finsterwalder on this construction, which is not a prefabricated hall. It's only designed, it's only built on the site. But what is interesting is that he is, so to speak, covering the market with a very interesting roof, the curved roof, so to speak, structuring the space, and you see the light coming in is also very important to create a very special space and a very special atmosphere. You have this kind of roads where you can go with cars or with staples or with other things. You have very minimized places where the columns are, so it's, by the way, it's at the same time a kind of structuring of the space, and you have a very spectacular outside facade, outside design. If you remember the market halls in Paris I showed you in the lecture of with steel, iron, steel and networks, then you can see that these market halls are very important for the all-day life, and it has a special, very special atmosphere. Unfortunately, it's not possible to go in as a normal person. You have to have a trader pass to get in, but this is I think it's a very interesting thing, and if you have the chance to go inside, you could use it. Parts of these market halls were used as a theater, and if the theaters are opening again, it's recommended to visit, for example, a Harry Potter show inside, and as you know, there is also a very interesting pavilion in the front of the building. Bernhard Hermkes really designed, so to speak, a cathedral of market. It's an extraordinary building. It's a listed building. It has a very unique form, and if you come in with a train from the south or from Berlin, you're passing these halls, and it's something like a monument. It's a very interesting thing, a monument of the market sales in the center of the city. Let me introduce you another engineer in this particular case, Ulrich Müther. He was working in the GDR times, and he had a construction company called VEB Spezialbau, and this company, in this very special economic system of the GDR, was responsible to design special buildings in the huge residential area, restaurants and swimming pools and these kind of things. Müther's company was based in Rügen, on the island of Rügen, and as an engineer he was very much interested in these kind of shell construction, as we saw it, for example, by Heinz Isler or Felix Candela, and so he, as an engineer, had this knowledge of technique, and he was working on the realization of these special buildings. And I'd like to show you some examples now. This restaurant, so-called Insel Restaurant, Insel Paradies, Island Paradise, on the island of Rügen in Barbe. On this picture you can see the situation in the 1990s and the early 2000s. Now I heard and read that it is reconstructed and recovered and is used as a restaurant again. What you can easily see on these pictures is that the construction is just made of one column, and the whole roof is covered by this one column, and he is designing this huge space. You have these small holes with the lights in, so it is very effective construction out of steel, concrete, and this particular shell. Well, another example is this very famous building, so-called Teapot in Warnemünde, Rostock-Warnemünde, very close to the lighthouse. And this is constructed in a classical way with a double curved shell, the hyper shell, or HP shell called. And in the same way, the restaurant Cosmos in Rostock is constructed with these double curved shells. And this is very typical work for Ulrich Müther, a restaurant in the residential area. And the residential area is just made out of these prefabricated system buildings, looking very uniform and monostructured, and this VEB Sonderbau, VEB Spezialbau made this very special and very interesting building inside to have a light up or something else like that. This building are really looking high-tech, and it is high-tech because you need a very precise calculation of the forces and the calculation and design of the formwork, and so it is not easy to construct, but it is easy to build. And if you know to design the form, and if you know how to do it as we saw it in the South American construction site, it is very easy to achieve a building you need, even if you have not enough wood or not enough bricks, for example. Then you have to be creative and to find another solution also for very simple tasks. A good example for that is this saving tower on the beach of Binz, which is a holiday resort on the island of Rügen, and Ulrich Müther's home is there, so it was very easy. And it looks really like a spaceship. If you see, there were two of these buildings. One they had demolished. You see it on the picture on the left down. And as we had the chance to meet Ulrich Müther, he told us lots of stories. For example, how they built this building. And it was very easy. They digged a hole in the sand on the beach. They covered it and formed, so to speak, a formwork in the sand, and then they put the steel network and the concrete in. They put it out, turned it upside down, so they combined two halves of it. If you look carefully at one of the pictures, you can see that there is a combination of two elements. So he was he said, okay, I'm an engineer, I'm a builder, but I'm not higher. I'm knowing the high tech, but I can realize the highly and complicated construction. I can realize it with simple hand things, and he was very creative to achieve these complicated-looking building with very simple, with some very simple tools. When we had the opportunity to talk to him, and I was with some students in Binz, and he gave us a lecture about his work, and he said, "I'm a Landbaumeister," which means I'm a builder for the people, especially on my island on Rügen. So he was also helping them if they have no materials, for example, no wood, no wooden beams, or no steel beams, or anything else to construct a roof, for example, for this sport hall in Ginst, which is also on the island. And then they say, okay, we have cement and we have sand, we have some network steel, these mats of steel to put into the formwork. And so he designed, so to speak, or constructed these double dome roof. It looks more spectacular than it really is. So you can't find it really on the island. It's very hidden somewhere. But when you come into this hall, then you see this fantastic roof without any columns and great enough for a sports hall. So he offered his very detailed high-tech know-how to produce very simple solutions and help the people to go along. So this is, for example, for me, a very special issue on this kind of architecture. Well, Ulrich Müther is an engineer. He's not an architect, but I think this is, especially this is architecture on its really original substance and understanding. So you have a simple task, you have a simple problem, and you can help it with a very special form, and then you achieve a nice space inside the building. This is the restaurant Seerose in Potsdam, and it's like the restaurant or the building we saw in Rostock. It's an addition to settlement, residential settlement. We're quite in the center of Potsdam. He used the form, you already know this form from the restaurant I showed you, designed by Felix Candela. He made it, or he designed it together with Peter Adling as an architect, but the form he used, and well, it's a very special form, dominates this building, and in this particular case, engineering and architecture is in one hand. Perhaps the architect is just adding the windows and the interior design. And if you look at the interior design, you see it's quite different from the outside building. And of course, it's very difficult to design the inside properly, because the form of this shell is very present and very very much present, and gives the whole building the form. Well, the last building I'd like to show you of Ulrich Müther's work is this music pavilion in Sassnitz. It's a touristic object, so you can listen to open air music, and the shell has a form to support the acoustics. He works together with Dietmar Kunsch and Otto Patzelt as architects and planners. And here also you can see that the constructed form and the architecture is a unit, and it's on the other hand, and this is also a symbol. So the architecture defines the space. It's something like a monument, which is also dominating the public space on the promenade of on the holiday resort of Sassnitz. It's also a working town, but it's very much based on the tourism on this island. Well, at the end of the lecture, I'd like to come back to other forms you were capable to do in the 20th century with the material of concrete, especially steel concrete. And I'd like to show you this example from the year 1910, 1911, Jahrhunderthalle, the so-called Century Dome or Century Hall, designed by the architect Max Berg in the former German town Breslau, now upon the Polish town's called Wrocław. The architect Berg, well, he comes back to the ancient kind of construction, and on the down on the right, I gave you another image of the Pantheon in Rome, and you see the analogy between these buildings. So he had some curved beams in the ring on the top with the lantern on the top, so the light comes in from the top, and you have the rings and the beams constructing these huge dome. But what is the construction company, by the way, is also Duckhoff and Wittmann, which were very famous for this shell construction. Achieved with these construction the greatest dome hall in the world. It has 65 meter in the diameter, and since that the Pantheon was the hugest building with these diameters. So then the record, they got a new record in this. The construction really follows the old principles of the Pantheon and the Hagia Sophia. In a way, if you look at the arches supporting a ring and then the dome on the top, well, this is not a rectangular building like the Hagia Sophia. It's a more or less round building, but the geometric elements are the circle and the half circle, a dome and the half dome. But the material is the difference. They built it out of concrete and steel, about steel concrete, and achieved a much bigger space. So that was this Century Hall or Century Dome was famous for. Interesting in this building is that you can see the construction. The construction is open, and sitting inside to follow a football match or something else, you see the open construction and you can follow the idea of construction. Another engineer architect who's following these principles, like Max Berg in the Century Dome in Breslau, was Pierluigi Nervi, the Italian architect engineer. For example, like building these Palazzetto dello Sport in Rome. And well, he's also optimizing this kind of construction, as we saw before, and he found a much more finer technique, much more fine technique if you follow the roof, for example, but it's still a construction with beams and well, it's not a shell like the shells we saw before, so it's something similar like the wooden construction, but he made it out of concrete and steel concrete. Well, he started this work in 1935 until 1941, and another example of his work is this airplane hangar in Oviedo in Italy. And here he goes back to a special wooden construction which was developed by Friedrich Zollinger at the beginning of the 1920s, that depends on the romp construction or a diamond hashtag construction, like you see it on under the roof of this building. And again, he just uses steel concrete to optimize or to extend the wooden construction before. And even Pierluigi Nervi is a very interesting engineer and or architect. I just showed you these two examples of his works, but there are lots of more stadiums and sports halls and airplane hangars and all these kind of things, where you need a huge space without columns, column-free. So this was the thing you can achieve with the material of steel concrete, especially when you're constructing it as the shells. For most of these constructions, you need the pre-stressed steel as a construction principle. And the problem with these things is that this is if water comes into the construction, then the steel is going to rot inside because it's open, and if it comes inside, it's rotten, and then these buildings collapsed. And that happened, for example, in Genua a few years ago when a huge bridge collapsed. And so this kind of construction becomes more or less out of fashion, and nobody is following it again because it is too you have to support it, you have to maintain it too much, and it was a little bit too dangerous, and it costs a lot. So it came out of focus in a way. But in the last years, Mike Schleich, the German, is making experiments with carbon to combine carbon and concrete, and so this extension of construction will get a new future again, and you can come back to these foams I showed you in this lecture, to these foams and space. Yes, thank you very much for listening. This was the 5th lecture, and we see us again, and then you can see the last lecture of this serial. Thank you very much for your patience. Thank you for listening. See you. Bye bye.